is it on the end of the table? No.
Okay, 9.2 arithmetic sequences in partial sums. So today we're going to recognize right and find the nth term of the arithmetic sequence. Today is about learning the formula. Like I said, it's the third time you've seen the formula, so you should go, oh yeah, I do remember this now, and go from there. I didn't say it yet, but when I show it to you. Okay, an arithmetic sequence is consecutive terms have a common difference, addition or subtraction. So 2, 7, 12, 17, 22, 27. What is your common difference? 5. So D is 5. Okay, negative 100, negative 80, negative 60, negative 40, negative 20. Positive 20. Okay, could it have been negative 20? No. Add or subtract. So if you're subtracting, it would be negative. So it could, no, but it could be on another situation.
Oh, yeah.
Like if it was negative 20, negative 40, negative 16. Okay. Which one of these is infinite?
They both.
The first one. Why, Sam? Because it has the 3 dots at the end. The first one is infinite. The last one is finite. It stops. Okay. Some of this coming back a little. Okay. Are the following sequences arithmetic? It's a yes or no question. On your test, it will be arithmetic, geometric, or nothing. Okay? But right now, it's just arithmetic. So I have 7, 11, 15, 19. Does it have a common difference?
Yes.
What? 4? So yes. And D equals 4.
The next one is
The next one is
no.
no. Why?
Because it goes up by 3, and then 5, and then 7.
Okay, so 3, 5, 7. So it does not have a common difference. Difference is addition, subtraction, right? So it is a no. Okay, so 2, negative 3, negative 5, negative 13.
No. That's negative
Yes.
8, but yes.
It's
No.
not negative 8.
No, you said negative 5.
Oh,
Negative
I
8.
gave away the,
It's negative 5.
yeah, I gave away the thing, sorry.
Okay.
In my head, I know I'm doing the math, and it came out my mouth. Okay, so it's negative 5. And you know how you find find that is you take the second minus the first. So negative 3 minus 2 should equal negative 8 minus 3 minus a negative 3. So be add, right? Which should equal negative 13 minus a negative 8. And they all get negative 5. So second minus the first should give you your difference every time.
And then third minus the second, and then fourth minus the third, and then fifth minus the fourth.
Okay, what about this one?
Well, the 1 is throwing me off. I don't like.
Okay, well, before I compare fractions, I should always do what?
Yes, it is.
Why, Alex?
Because 6/4 is 3 over 2.
Okay, so the first thing I should do is get common denominators, and that's what he did. So you have 4 fourths, 5 fourths, 6 fourths, 7 fourths.
Oh, yeah, duh, 4 fourths. I was so confused with the 1.
So, yes, the difference is
2 fourths? 1 fourth.
1 fourth.
2/4.
Because it's 5 fourths, 6 fourths.
No, it's
7
1
fourths,
fourth, 5 fourths, 6
Oh.
fourths, 7 fourths. Isn't that just adding 1 fourth?
Yeah.
Sure.
Okay, so if you have a fraction, you should be getting common denominators. Now, here is their rule, equation, what other thing we could find it? Rule, equation, formula for those sequences. A sequence is a list of numbers. Yes? Okay. A sequence is just a list of numbers. What do you notice about the yeses? And the no's, I guess. What's different about the no?
The no was squared.
The no is squared, so that's the multiplication going on, right? And when you square a number, you're not even multiplying it by the same thing, are you? So that's like a no on geometric, too, when we get there. So what do you know about the arithmetic? So what do you see? And these are written as 2 terms, yes?
It tells you.
These are written as 2 terms, yes?
Mm-hmm.
So can we write this as a 2 term? Could I put 1/4 n plus 3/4?
Yeah.
Yeah. And Olive, what'd you just say?
It like tells you.
It tells you. It tells you the common difference. Where is the common difference? Big math words, use it.
With the N.
What is that with the n?
The leading coefficient.
Yeah, the leading coefficient, or just coefficient in this case, because I could, in like 7 minus 5n, it's not leading. But yes, it's the coefficient, right? The coefficient of n is going to tell you what your difference is.
Oh, dang.
What do you think the other number is?
1, 4. What are you talking about?
Like the 3, the 7, the 3/4. What do you think that is?
The
What you-
geometric one.
No, that's what you add to get the first number.
Yeah, it's your initial thing.
Dang.
Okay? Because remember, this is a sub 1, so we plugged in a 1 to get it. And this is a sub 2, so we plug in a 2 to get it. So 2 times 4 is 8, plus 11, plus 3 is 11. A sub 3, 20, not 20, I'm doing the 5. 12 plus 3 is 15. A sub 4, 16 plus 3 is 19. So the last 2 years when you've gotten the formulas, last year I just told you the formula. I know in Algebra 1 he just told you the formula. Now do you really understand why the formula is the formula?
Yes.
Okay, so I'm going to give it to you broken down right here. Like I said, it finds any term. It's the formula. It's the definition. You'll hear me say rule a lot. Does that all mean the same thing? Yes. Rule, definition, formula. It gives you the equation to give you the sequence. So a sub n is any term. A sub 1 is the first term. N is the number of term you're finding. And in the formula, this is like your y and this is like your x, so we don't fill them in. And your d is your what? Common difference. So there are 1, 2, 3, 4 unknowns in there. As long as you have 3 of them, can you find any of the other ones? Yes? So will I be asking for like n? Yes. Will be I asking for a sub 1? Yes.
I'm good.
I think Olive's still working.
On page 2.
You're confused?
On page 2.
Oh, I thought you said you're confused. I was like, we haven't done anything. Okay, find the formula for the nth term of the arithmetic sequence whose common difference is 3 and whose first term is 2.
So,
A sub n.
2.
not 2.
2 plus n minus 1, 3.
And this is times 3, right?
Mm-hmm.
Okay. So, now what? Distribute. So a sub n equals 3n, and then negative 3 and positive 2 would be negative 1. So the nice thing about this is now can I find any term I want? Yes. This is called an explicit definition, meaning I can find any term I want. Recursive means I have to reoccur and do it more often, and you'll see that in a minute. They're not the fun ones. Why did it go back to that one? Isn't it the same one? Okay, try this one on your own. Okay, did it go okay?
Mhm.
Now, I'm going to tell you the book will probably write it like a sub n equals 4 minus 5n. And I, a lot of the times, do that too. Why do you think?
Positive comes first.
Yeah, putting that positive first so you don't forget about the negative. But sometimes you have both negatives. Now, proper form would tell us we should put the n first, right? I don't care which one you put. Just know that it can be written both ways. It doesn't matter where it's placed. It matters the coefficient, right? Okay. Find the 10th term of the arithmetic sequence that begins with 8 and 20. So the assumptions we can make, since it tells me no information, it begins with 8 and 20. So 8 is a sub what? 1. And 20 is a sub 2. Okay? So if it wants to be a sub 6 and 20, they're going to say a sub 6 is this and a sub 20 is that. Does that make sense? Okay. So what do I need to do here then?
But a sub 1 is,
Oh, a sub 1 is 8. Thank you.
Well, they're not a common difference.
I don't, but I know two consecutive numbers.
16.
How'd you get 16?
You mean 12?
That's what I said.
So the difference is 20 minus 8, right? Which is 12. And so then my equation is 8 plus or minus n minus 1 times 12. So a sub n is 12n minus 4. Now is it all coming back to you now?
You just stop there.
That's the equation. That's all I needed. Oh, no. Sorry. I wanted the 10th term, so now I do what? Plug in a
10 for
10. So a sub 10 is 120 minus 4. Here's your 16. 116. So when you do these problems, I'm looking for this and this. Okay? Thank you, Alex, for pointing out. Just start there. Depending on what they ask, right? That's not what they asked. Questions? Concerns? Okay. Write the first 5 of the arithmetic sequence. I have the first one. So there's a couple different ways we can do this. We can write a formula and plug in 1, 2, 3, 4, 5. Or could we just add 0.25 to get to the next one? Right? So what way do you want to do it?
16, just add.
Just add. Okay, so a sub 1 is 16.5. A sub 2 is a sub 1 plus 0.25. So that'd be 16.75. A sub 3, and I'm writing this a long way out, but I'm doing it for a reason, is a sub 2 plus 0.25. So 17. Tell me if I'm adding wrong. So a sub 3 plus 0.25. So 17.5 or 25. And a sub 5 is a sub 4 plus 0.25, which would be 17.5. Do we need to do any more of those? No. Could I have written the definition again? And plugged in 1, 2, 3, 4, 5. Yes. Now, would plugging in 1, 2, 3, 4, 5 in this equation be more difficult than just adding 0.25 in this scenario? Yeah, your brain would have to do some more work, and we like to be efficiently lazy, right? Okay, now I want the first 5 terms, but what did I do to you?
That's 4 and 13.
I guess 4 and 13. So, this is what we got to do. We got to figure out a sub 1, and we have to figure out d, don't we? So we can write a formula. So we can.
It's 5. I'm convinced it's 5.
Okay, but we're going to, I don't know if it is or not. I don't remember. So we're going to do this. This is how the easiest way I think. So we have this formula that, and I touched it. We have this formula that says a sub n equals a sub 1 plus n minus 1 d. Yes?
Mm-hmm.
And I have 2 points. Like I have 2 points, right? So if I plug that information in, should I be able to find d? Yeah? Okay, so what I like to do is make this a sub 1 for right now. So if 4 is a sub 1, what does that make 13? A sub 10. How did we get 10?
That would be the subtract 3.
4 minus 3 gave me 1, right? I had to bring it back. Okay, so now can I plug this information in here? Yeah, a sub 1 would be 20, right? N would be 10. Yes,
Oh.
minus 1. And the a sub n would be the amount, because we actually have it, would be 65. Guys, please be careful. Do your math and do your problem correctly. You know what a lot of people do on this one? They take 20 and add it to 9. What is wrong with adding 20 to 9?
They don't have the same variable.
Yeah, they're not like terms, are they? Sometimes I tell people subtract or move the 20 over before you even do anything. Maybe that would stop. I don't know. I see it all the time and I don't know why. Okay, so I get 45 equals 90. It is 5. But we probably should do that mathematically and not just go, oh, my instincts tell me. Okay,
Okay, no, I have a question. Now.
what?
So, like, with that one, I figured out it was 5. Well, because I just multiplied. But then, also, if you just take 13 minus 4, that gives you 9, 65.
But that's what we did right here. That's everything you're doing is what we did in this step.
Do I have to do the whole formula? Like, if I just know 65 minus 20 is 45.
Well, you have to give me
34
something.
is
You have to
9.
give me something how you found that D was 5.
So if I just wrote 45 divided by 9, it would work. Like 65 minus 20, and then 13 minus 9.
Yes, but that's what we did.
I know, but I don't know.
Okay, my thing about using the formula, it makes you more familiar with the formula and you can use it easier.
Yeah, okay, that's fine.
Okay, and I am going to tell you right now, there is going to be an arithmetic sequence question, at least one on the ACT.
Okay.
And you, in order to be efficient at the problem, you need to know the formula. Okay, because you can solve the problem without it, but it's going to take you too long. And especially with arithmetic, I want you familiar, be able to like perform it in your sleep. So what you're doing is the formula, you're just kind of rearranging. It's like when you first do algebra, you're like, well, I can just do this. And we're like, yeah, but your problems are going to get harder. And does that make sense?
Yeah.
Okay, so now that I have the difference, can I go back here and do the same thing again to find a sub 1? Yes. So now that I have the difference, I go back to the original and pick one of them. I don't care, a sub 4 or a sub 13. A sub 4. Okay, so we're going to do the same thing. But this is going to be my a sub n now, and my n is going to be 4. So then 20 equals a sub 1, because that's what we're looking for, plus n is 4 minus 1 times 5. So 3, so 15 minus 15. Evidently 15 looks like 51 in my head today. So a sub 1 is also what? 5. So now that I have a sub 1 and I have my common difference, can I write an equation to plug in 1, 2, 3, and 4 too? Okay, so a sub n equals 5 plus n minus 1 times 5. And guys, once you do that, I would expect by the end of the day, you're just doing this in your head and going 5n, well, that would be plus 0. Does that make like, are you already basically just doing that in your head, simplifying it?
No.
No? Okay. You too. You fallen asleep?
No.
So now that I have my formula, my rule, my definition, I just plug in 1, 2, 3, 4, 5. So a sub 1 better come out to be 20 because, no, never mind. A better come out to be 5 because we said 5, right? So 5 times 1 is 5. A sub 2 is 5 times 2, which is 10. A sub 3, 5 times 3, which is 15. A sub 4, 5 times 4, which better be 20. Why should it be 20? Because it says it at the beginning, right? And 5 times 5 is 25. Again, could I just added 5 every time? Yep. Now if I wanted a sub 123, you're not going to do this 123 times, are you? You're going to take, you would?
What did last year?
Well, hopefully you've matured in your mathematical ability. 615.
Okay. You have to flex on this.
Really? 1, 2, 3. That's
5 times 2 is
5 times 3 is 15. Carry a 1. 5 times 2 is 10. Plus 1 is 11. Carry a 1. 6.
Yeah, do you didn't know that?
I didn't know it. I did it. Okay. What are we going to do?
First 5 terms.
First 5 terms, but I gave you 8 and 12.
So we wrote that 1.
So this is a sub 1. And so this is a sub 5. How are we getting from 1 to...
It took me too long.
Because from 8 to 1 is minus 7, yes?
Okay.
Okay. So, what's the formula that we got to know?
A sub 1 equals,
A sub n?
A sub n equals A sub 1 plus n minus 1 times d.
Okay. Hopefully you said that without looking.
Mm-hmm.
Okay, that was so convincing. Okay, what goes in here?
25 plus. Okay.
A sub n is the last one, the last thing. So 41 equals A sub 1 is what? 25. Plus, what is n?
5.
5?
How did we get that?
Because it's right here.
Minus 1 times.
Because if this is A sub n, n is 5. Okay. So minus 25 divided by 3.
3, 4. It's 4.
Oh, it's 4?
And it's
Okay.
equals 4.
Sorry. So D equals 4. Now what?
Oh. Then we plug it in.
Okay, so we go back again, and you pick one of the originals. Does it matter which original you use?
No.
No?
Well, let's do 25 because it's small.
That's usually what people do. Okay, so 25 equals a sub 1, because it's
Plus 8 minus
8 minus 1 times 4. So 7 times 4,
Wait, what did you guys?
what?
8? Oh, from a sub 8?
Yes.
Okay, where did you get the 5 the first time? Again? Like 5 minus 1. Where did you get that?
Oh, because this is a sub 1, and so this is a sub 5.
Oh, okay.
So minus 7. Okay, so 7 times 4 is 28. So a sub 1 is negative 3.
That doesn't make sense
Why?
What's 25 minus 28?
because it goes up when you go.
Yeah, it does go up, but you're starting, in order to get these numbers, we have to, yeah, that's a sub 1. Oh, I didn't put a 1, sorry.
I was thinking there was a difference.
Right. Yeah, the different, but yeah. So if the difference is negative and the numbers are going up, you are doing something wrong. But that's good that you're thinking about it, Alex. You're not just like brain deading it. Okay, so a sub n equals negative 3 plus n minus 1 times 4. Okay, so a sub n equals 4n minus 7. Is that right?
Yeah.
Okay, so now I plug in 1, 2, 3, 4, 5. So 4 minus 7, so negative 3. And that's it, our first check, right? Why? Because did we say a sub 1 was negative 3? Yes. Okay, a sub 2 would be 8 minus 7. 1. A sub 3, 12 minus 7. 5. A sub 4, 16 minus 7. 9. A sub 5, 20 minus 7, which would be 13. Now, I could keep going to 8, but I'm not going to, and neither are you. Are you? No. Are all of my numbers changing by 4? Yes. Okay. To write them as a sequence, we would write negative 3, comma 1, comma 5, comma 9, comma 13. And then does it go forever? Yes.
Is this all we're doing today?
Let me see if I have one more example. Because they're all different. I mean, they've all been kind of different. Let me know when you're good, Alex.
I'm good.
Okay. Now, recursive, which I kind of hinted to. And I think this is the last one we're doing. Okay, so explicit is what we've been doing. Okay, we could plug in any number of term and we could find it right away. Recursive is recursive. Recurse means to happen over and over and over again. So with recursive, you have to have initial conditions, at least one. You could have multiple. Last year I shared with you Fibonacci sequence. That was 1, 1, 2, 3, 5, 8, 13, 21. Does anybody see the pattern yet? 40, 34, 55, 89. No one's seen the pattern yet?
You're adding, so it's the second plus the first, the third plus the second.
So 1 plus 1 was 2. 2 plus 1 is 3, 5. Okay. So the Fibonacci sequence is one of the most famous recursive definitions because they can't find an explicit. They can't figure out an equation like we just did that gives it to you. With many, many, many other recursive definitions, they've figured out the explicit, so it's more efficient, but they can't. The other thing cool about the Fibonacci sequence is it's so weird because if you picked any flower, when it first blooms and counted the number of petals on the flower, it would be a number in the Fibonacci sequence.
That's weird.
Did you know the pines, like the little pines on a pine cone, the actual spiral up? Okay, each of those spirals is a Fibonacci number, each one. So they don't really, bees, they reproduce in Fibonacci numbers. They don't know why. It's a number that occurs in nature all the time. Like these numbers. Fibonacci numbers is some number in the Fibonacci sequence. And they don't know why. It just happens. It's kind of cool. Okay, so the Fibonacci would have two initial conditions because you'd have to start out with 1 and 1. Okay? But all the ones we're going to deal with have one initial condition. I've worked with recursive definitions that have like 5 initial conditions. So it tells you. Okay, so it tells you my first term is what?
72.
72. And what does it tell me I'm doing to every other term?
Minusing 6.
Minus subtracting 6. So the hint that it's a recursive is this right here. That a plus 1 means to get to the next term. The other way they could write it is a sub n equals a sub n minus 1 minus 6. So this one says to get to the next term. This says to get the term, go to the last term. Okay? So if you see an initial condition and you see something like this or this, you look at it, say it's recursive. Where do I start and what do I do? That's it. Don't look at anything else. Where do I start and what do I do? Make sense? So a sub 1 is 72. So a sub 2 is 72 minus 6. So 68? No. 6. Can't subtract. A sub 3 is 66 minus 6. A sub 4 is 60 minus 6. 65 is 54 minus 6. Now, I know we're pushing it here, so it's 48, yes? Okay, what if I told you to give me an explicit definition from this? Could you? Do you have a sub 1?
Yeah.
Do you have the common difference? So can you write an equation? Yes. You would just say 72 plus n minus 1 times negative 6. So negative 6n plus 78. And there would be your arithmetic explicit definition. Remember in the first slide when I said, what do you notice about the definitions? And Olive said it tells you the difference. Is it still telling you the difference? Yes. And that was our last example. Sorry, guys, I ran over.